Hello, this is Nitin Dahad with the Times. I'm here at the NI Connect conference in Dallas-Fort Worth in Texas, and there's a whole bunch of exhibitors here and partners. One of the companies I picked up on is RADX, and speaking to Ross Smith, who's the CEO and founder of RADX, a long history in Silicon Valley. Hi Ross, how are you?
I'm good, thank you.
So, I mean, you're doing something very interesting, which is GPUs on PXI and especially Blackwell.
Yes.
But we'll go into that a little bit. Just tell me a little bit about you and your background, because you've got quite a good background in this industry.
So I've been in Silicon Valley since about 1982, and I've done over a dozen startups. I was at MIPS in the early days.
With John Hennessy?
With John Hennessy, yes, and Skip Stritter, and Bob Miller and the crew, and Joe DiNucci, of course.
Oh, yes.
And then left that and went to Silicon Graphics. And at Silicon Graphics, a group of us spun off a technology into a company that was doing graphics called Pellucid.
Yep.
And at Pellucid, there were a bunch of us there. We were working on developing advanced graphics for PCs because SGI wasn't interested in that. And then we were acquired by a company called MediaVision.
Yes.
And we left, we all kind of left, and half of us started a company called 3DFX, and the other half started a company called Nvidia. And the rest is kind of, history. So 3DFX...
Still on parallel paths, though.
Well, we were for a while.
They were, yeah.
And then after, 3DFX was quite successful. We were focused on video games.
Yes.
And then I left 3DFX and started a company called Quantum 3D. And we were taking 3DFX silicon and building advanced image generator products for flight simulators and embedded graphics. We put the first embedded graphics in like the F-22.
Okay.
So I have a long history in graphics and things like that.
Right.
Fast forward several years.
2011.
Yeah, 2011 we started RADX. And there, a buddy of mine, actually my lab partner from college, was working at BAE Systems, and they had developed a tester for the F-16 based on this thing called PXIe technology.
Right.
And so he invited me down. He was in San Diego, so I went down to look at this thing, and I said, well, that's pretty interesting. And it was a software-defined instrument. So instead of being a fixed function instrument you might buy from Keysight or Rody Schwartz, you could program it.
Yes,
so you could program this instrument, and because it consists of a backplane with modular cards that plug into it and talk to each other, it has a built-in computer and things like that. And so I thought that was kind of interesting. So he asked me to spin out that business from BAE Systems and start a company, and that became RADX.
Interesting, okay.
So, and so we did that for a while, and then he wanted to move out of California. So we sold that business, which was called Liberty GT, to a company called Tebbit, which was our distributor. But at the time, we were building a module as part of our instrument family that was a solid state disk drive.
Okay.
Because we were building record and playback, and that's an integral part of that. So when I sold off the instrument, I kept that one module because I have a history in embedded electronics.
Yeah.
I said, I'm going to make a module company.
Which is what this is now.
Which is what we do now. So now, go ahead.
Sorry, go ahead. So fast forward to today, you've got some interesting boards using GPUs, but doing some interesting applications.
Yes, and so we started with one storage module, and that has evolved into about 15 different modules in different areas. So we build storage products, networking products, and our most recent adventure has been GPUs.
Yep.
And we're the first company, actually the only company to ever build GPUs for PXI.
Yeah, and you've got some examples here.
I do. So,
and this is Blackwell.
Well, actually, this is the T400.
Okay. Yeah.
So this is an older GPU built for a very specific purpose. It's an Nvidia Turing class GPU.
Yeah.
This is a very inexpensive product. It's only $2,500, and it's meant to solve a security problem with older embedded controllers in PXI.
Right.
So this is kind of a special purpose, but most of our customers buy a product that looks like this, this is a Blackwell.
Okay.
This is a Blackwell RTX Pro 2000. We just launched it at the show here.
Okay.
Now
we launched it today, I think. Yeah,
yeah, exactly.
Yeah.
Yesterday.
Okay.
Today's Wednesday. So this is a 17 teraflop GPU. It runs 70 watts, and we've crafted a solution that fits in the PXIe backplane using this technology we call Catalyst. And so this far surpasses anything else that you can get in PXI. and we can get all the benefits of GPU processing now in this, embedded form factor.
And that's going into that NI frame.
That's right.
For the
That's
testing.
right. That's
Yeah,
right. And so we've made now probably 15 different GPUs. Blackwell is our newest. That's the
$13,000, I think, retail.
This one is 10.
Okay. Yeah.
The one that's driving these applications is $13,000. That's the 4000 Pro SFF.
Okay.
But it's really interesting. So this has 16 gigs of memory, which means it's suitable for even doing training on AI.
Yeah.
The 4000 Pro has 24 gigs of memory and 400 gigabytes per second of bandwidth.
I mean,
it's awesome.
Just tell me what kind of stuff you're doing with that, because there's 2 demos here which show what you can actually do.
Right.
So just explain that.
So a lot of our customers, PXI has been an important platform for doing signal processing for a long time. And it's been dominated by the FPGA.
Yeah.
And FPGAs are really good at doing some things, but they're also notoriously difficult to develop for.
Yeah.
You have to create, the firmware in VHDL, you have to compile it,
Yeah.
you have to wait for it to compile, meet time and all those things. With a GPU, you just write software.
Right.
And so it's a very different development environment, but it actually does some things super well. So like it does floating point exceptionally well, and it has performance levels that you really can't achieve any other way. So signal processing, which has been a domain for PXI, fits really well on GPUs.
Okay.
So this particular example, we're streaming data from a National Instruments vector signal transceiver, which is a fancy name for a software-defined radio.
Got it.
That's in PXI, and it's streaming 1.25 gigasamples per second of 16-bit IQ data to the GPU, where we're processing it from time domain to frequency domain with 1 million point FFT.
Right.
And if you've ever tried to do that in an FPGA, you would never try to do that in an FPGA. It's almost impossible.
Okay. No.
And with this, we're able to get a resolution bandwidth that's tiny, so 2.4 kilohertz across a 1.25 gigahertz spectrum. We're doing, a 1 million point FFT. We're doing about 1.2 thousand FFTs per second, and we're doing a probability of intercept of 1.68 milliseconds.
Yeah.
So
pretty fine, granular.
this is the highest performance real-time spectrum analyzer on the planet.
Okay.
And it's software defined in an NI PXIe chassis.
And so you're quite pleased with that, I guess.
Well, I've built my own RTSAs before. In fact, my Liberty GT product had the record before this, and that was FPGA based.
So you've launched 2 products. There's this with the Blackwell. And then there's something else for...
Right, so we did, and we'll talk about this other demo in just a moment.
Yeah.
But we launched this T400 product because PXI is well known and well used as a long life cycle platform. People, they don't replace them every year because they make quite an investment in their PXI systems, so they expect them to last. But all COTS products have a life cycle.
COTS being?
Commercial off-the-shelf products, which is a common thing that we all want to use because it's less expensive than something that's custom.
Yeah.
The inside a PXI chassis is an embedded controller typically. You can think of it as the motherboard.
Yeah.
It's got a processor, memory, disk drive, and all those things. And in that particular situation, the flagship embedded controller from National Instruments, the PXIe-8881, which is about 6 years old in terms of its life, the GPU that's on board, which happens to be an AMD Radeon GPU, has gone end of life and end of service. But people want to run Windows 11 because you stay up to date with security, and you can't run Windows 11 on that GPU.
Got it, yeah.
So you can either disable the GPU and use the standard Windows driver, which is not so great, it's about a 1987 graphics experience.
Okay.
Or you can turn off that, you can turn off that part of Windows security, and then you have a security problem.
Yeah, exactly.
With CMMC, or with NIST 800. So we brought out an inexpensive, it's $2,500 GPU for this market.
That's a T400.
That's a T400 that will give them multi-monitor output, which they've never had before, plus an Nvidia graphics experience. And so it's a really low-cost solution to what really is a security problem that we happen to address with an Nvidia GPU.
Okay. And what have we got there?
So this demo, of course, is a spectrum analysis signal processing application. So this demonstration we're doing here is actually using 2 GPUs. So we have a computer vision application using an algorithm. It's a CNN. It's a neural network application, and this is common. You see this in autonomous driving, and so it's called "You Only Look Once." So you can see there's a plate up here with parts on it, and the assumption here is that we're expecting the assembly to have 10 nuts, 9 washers, and 5 screws, and we're doing computer vision to make sure that's what's up there. So if I go up here and grab a bolt, you can see now that we failed, right?
Oh, okay, yeah.
Now if I put it back,
you
see we passed again. So it's a classic, and our partner, ADS, builds these computer vision applications for all kinds of people that are doing this kind of application. So we're running the computer vision application, and in addition to that, we're running a large language model, in particular a Gemma 4 31 billion parameter large language model.
Okay.
And that's running on the Blackwell in the chassis that's air-gapped, no cloud. And for a lot of defense customers, that's really important. So we have the LLM talking to the instrument that's doing the computer vision. So now I can control what is otherwise a fairly, esoteric application with English language.
Got it.
And that has a lot of implications.
Indeed.
So we can say, I can tell it, okay, so how many screws do we have? So it says there are 5 screws. So I mean, it's a really simple application, but the power of this is important, and it's enabled by the fact that we have a Blackwell GPU now that goes in PXIe.
Okay, what's next? I mean, it all sounds exciting. You seem to be taking advantage of both your experience and your history, and applying it to what's today. What's next?
Our business model is kind of looking at the roadmaps that NI and the other people in this ecosystem have, and basically trying to see where are there important gaps. So for example, we build a lot of products that are high-speed data storage. Removable, very large. We started out doing RAID modules, and then after that we switched over to using U.2. Okay. So U.2 is in a data center form factor. So we replaced our RAID product with a single drive, and then we're building a bunch of variations on this theme. So this product can go up to 61 terabytes and 7 gigabytes per second. So in record and playback applications like autonomous driving, this becomes a really important component. Okay. So we have a lot of customers now that want different variations on this theme, so we'll do some more innovation in storage as well.
Wow. Yeah. It's all exciting stuff, isn't it?
It's, for a nerd like me, it's a great pastime.
Yeah, I mean, I think we both have a little bit of history in this. But it seems like what we started in the 80s is kind of evolved into something really fascinating now.
And it's very practical. I mean, our stuff is used by companies in all aspects of engineering, so defense, aerospace, automotive. My biggest customer for this product is automotive. Okay. Yeah. So you may have heard that there have been a lot of recalls of vehicles because of their cameras. Yeah. So this is used in a camera tester. And so it's a good motivation for companies to buy camera testers instead of doing a $2 billion recall.
And it's pretty cheap.
Relatively speaking, I mean, there's a premium for PXIe. The thing that's gotten expensive now is the SSDs. Got it, yeah. So I was buying SSD, I could buy an SSD, let's say an 8 terabyte SSD for $1,000 in December. That same SSD is $3,000 to $4,000 now. Yeah, exactly. So huge uptake in SSD pricing.
Good. Well, Ross Smith, thank you very much for the conversation. And
it's my pleasure, thank you.
Thank you.
Nice to meet you.